This video is Unit 8.4, and it's about inverse trigonometry ratios. First of all, we have to know what is the inverse of the trig ratios. And if we have sine, cosine, and tangent ratios of an angle, we can use something called this, an inverse. And it's spelled out as sine inverse, cosine inverse, tangent inverse. And please do not say sine -1. That's different from sine inverse. This stands for sine inverse. And we use that to find the measure of the angle. So again, trigonometry ratios really establish a connection between the angle measures and the side length in the right triangle. So let's look at how we use that. Over here, we have angle x. And then we have the hypotenuse. We have the opposite leg. So we know sine x should equal opposite 15 over hypotenuse 24. And in order to write it into an inverse, we do a circle dance. We do sine inverse to the other side and then come back to the x. So what I mean by that is I do sine inverse of 15 over 24 should equal x degrees. Notice that x is the angle measure, whereas 15 and 24 are the side length. And if you plug this in your calculator, you will see most likely you have to do a shift key or a different color key. You will find the inverse, sine inverse, on top of the key that says sine. So make sure that you do sine inverse of 15 over 24, and you should arrive at x equals 38.7 degrees. Let's look at example 4 here. I have an angle here. I have adjacent, so most likely I'm going to do cosine of x over adjacent over 23. And if I have to do my circle dance here, right, I do cosine inverse of 18 over 23, and then come back to the x. And you plug the left-hand side into a calculator. That should give you x equals 38.5 degrees. Okay, so the rest of it should be the same, whether it's sine or cosine or tangent. They are the same process. You write out the definition of sine, cosine, and tangent, and then do an inverse by doing the circle dance, plug it into your calculator, and get your final answers. So these slides give you some review. Number 7, find the value of x. Now I'm asked to find the side length. So you simply do a definition of 10 of 39 should equal opposite over adjacent. X should equal 11 divided by 1039 degrees. Right? And use your calculator. X should be 13.6. Let's look at number 10. Number 10, I have opposite and adjacent hypotenuse. Opposite over hypotenuse should give me sine of 24 degrees. And x should be 11 times sine of 24. Use your calculator. X comes out to be 12.6. The rest of them are fairly straightforward. I'm going to do number 11. I'm asked to find DE here. Okay, and I'm given this angle. It looks like it's probably easier if I do this one. So if I do 10 of 19 should equal opposite DE, which is x, over adjacent. Adjacent, I'm going to call this y. I don't have x, I don't have y. So let me look at the big triangle CDF. Over there, I have 61 degrees. And I can set up a relationship of tangent 61 should equal opposite, which is y, over adjacent, which is 24. So through this, you notice that I can find the value of y. and y should be, 43, I think, 43.3, right? Now if I come back to here, I have my tangent 19 degrees equals x over 43.3. And my x is, if I multiply 43.3, I should have 14.9. And that's my DE. That's my ultimate solution there, right? So in other words, if you started out with this side, you immediately find 43.3, then you move on to this side, step 1, step 2, that's perfectly fine. I didn't. I went backwards, and then I got stuck because I have 3 data points and I only know 1. So I needed to go to the second triangle to look for the value of y. So I went backwards a little bit. I hope that's okay with you guys. If not, walk through this again or come back to class and ask me questions about it. Okay? I'm going to skip this one. Most of these translations are fairly straightforward once you graph them out. Let's look at this one. What do we use trigonometry for? We use trigonometry to find missing sides. So this is several examples here. I'm going to do one and you can fill out the rest of it. The first one, I have an angle, I have a side, and I'm looking for the other side. So then I can use trigonometry. What I'm looking for is the opposite side, and I know the hypotenuse, so sine is my best friend because it's opposite over hypotenuse, and x equals 25 times sine 42. With a little bit of calculator help, I should have x equals 16.7, right? So we use trigonometry to find sides, and again, I need 3 data points here, and as long as I need 2 data points here to find the third one. So because look here, as long as I know 2 out of the 3, I should be able to find the third data point. And we also use trigonometry to find missing angles. And very often when we try to find missing angles, we use the inverse actually. So let's look at the example. The first example, I have 9 over there, 20, and x, and x is there. Sorry about that. There we go. So x is there. So if I have tangent x, should be opposite over adjacent. And if I do my circle dance, I do tangent inverse of 9 over 20 should equal x. I singled out the x. Now it's just calculator work. I use tan inverse of 9 over 20. Your calculator should spell out 24.2 degrees. Okay? Also, just as a side note, the reason that I do this circle dance is that in the very near future in Algebra 2, you're going to learn about a logarithm. And for some students, that could be confusing. And a lot of the transformations in Algebra 2 actually can use this circle dance and make life a lot easier, and because there emerges a pattern there. So let's look at the one at the bottom right. I have the angle being here. I have 2 sides, and one of the sides is hypotenuse, the other one is the opposite. So therefore, its sine of x should be 21 over 28. And again, I write it. I want to know the x, so I do my circle dance. I would single out the x. And if I use my calculators, my x comes out to be 48.6 degrees. Okay, so that's it about trigonometry and its inverses. It's not that hard. It's intimidating at the beginning, but if the more you practice, the more fluent you become, the easier it becomes. And this part is the foundation of pre-calc. So make sure that you understand where these trig ratios come from and how they are defined. And I will see you in class. Bye, guys.